This is Introduction to General Chemistry, and if you take General Chemistry from me, we'll actually be talking a little bit more detail about electrons and where they're at around the nucleus. And we're going to talk more in detail about these, what we call these four quantum numbers to totally describe the kind of the status of an electron, or what we call the zip code of an electron. But just to kind of briefly let you know, N we talked about, that's the principal energy level. L is actually going to be the subshell, and we'll talk about that a little bit more, an L value here in the next part. And then the M sub L is the specific orbital. So for instance, a little bit ago, I kind of talked about the P sub X or P sub Y or P sub Z, because P actually, remember, it's a P-type subshell. There are, what, 3 orbitals, and they are unique, so that's kind of what the M sub L does. And the M sub S we talked about, and actually that's what this slide is. The M sub S is what we call the spin number, and options of spins are values of plus 1/2 or minus 1/2. And I say we already talked about it, and kind of the purpose of this slide is to say, so what's that? That's an orbital, right? I'm going to go ahead, and how many electrons can I put in it? I can only put 2 electrons in it. And if I put 2 electrons, I need to show them one pointed up and one pointed down. So finally, we have now, this would be our M sub S is equal to plus 1/2, and this is our M sub S is equal to minus 1/2. That's all it is. Okay. So the Pauli's exclusion principle actually says that, for instance, if you have a set of electrons around a carbon atom, carbon is, let's see, how do I say this? Carbon is atomic number 6, so carbon has 6 protons and it has 6 electrons. Pauli's exclusion principle says for those 6 electrons, they have to have a unique set of these 4 quantum numbers. So that's to say, if you do have any of those 6 electrons sharing a same box or same orbital, then you need to designate them as being unique by their spin. I hope that works for you. Pauli's exclusion principle. An outcome is basically kind of one of the things we already talked about. Any orbital can only hold 2 electrons, and they will have opposite spins. So just to kind of wrap things up, and we're going to carry this part into the next part about how do we designate how electrons are hanging out. But anytime, for instance, you have electrons in an S-type subshell, an S-type subshell can only hold 2 electrons. A P-type can hold 6, a D-type can hold 10, and an F-type can hold 14. I kind of wish there was one more column added to this, so we could add a column that says number of orbitals. Okay, and there's only 1 orbital for an S-type, there are 3 orbitals for a P-type, 5 orbitals for a D-type, and 7 orbitals for an F-type. And then if you take each of these times 2, that's when you're going to get the number of electrons that you max out at. Okay, so this whole part is important rules on, in our universe anyway, how electrons are allowed to hang out.